Welcome back. So we talked about the basics of the polar coordinate system. We're pretty familiar at this point with the basics of the Cartesian coordinate system. Now I want to remind you that very back at the beginning of the term, we talked about when we had the points on a circle. Nope, it won't do that. Okay. So I've just got a part of a circle with radius r. And we talked about a point here. So this would be the point r theta. But we know that this guy's got xy coordinates too. And if you remember, we know something about that situation. We know that x equals r cosine theta. And we know that y equals r sine theta. And we know that x squared plus y squared equals r squared. And those three relationships still hold. So what that means is that we can go back and forth by realizing that this means that cosine theta equals x over r and sine theta equals y over r. And we can do a little bit of work and realize that tangent theta equals y over x. So this allows us to convert from polar to Cartesian. So let's find the Cartesian coordinates for the point with polar coordinates r theta equals 5 2 pi over 3. Okay. So we can do this. X equals r cosine theta, which means x equals 5, because our radius is 5, times the cosine of 2 pi over 3. So cosine of 2 pi over 3 is negative 1/2. So this is 5 times negative 1/2. So x is negative 5/2. Now we also know that y equals r sine theta. So that means y equals 5 times the sine of 2 pi over 3, which is 5 times root 3 over 2, which is just simply 5 root 3 over 2. So that means that my xy coordinates are negative 5/2, 5 root 3 over 2. All right, so now let me show you something about Desmos. Desmos will gladly display a polar coordinate grid for you. But if I put on the point, if I just type in the point 5, 2 pi over 3, Desmos does not give me what I want, because that is not a point on a circle with radius 5. If, however, I go back to a polar grid or a rectangular grid, we can see that that is definitely on an x equals 5. Desmos always reads ordered pairs as xy's. So if you want to see where a point lands on the polar grid, what we need to do is give it 5 cosine 2 pi over 3, because x is a radius times the cosine of 2 pi over 3, comma 5 sine 2 pi over 3. And now Desmos puts that point, sure enough, on a circle of radius 5 at 2 pi over 3. And if you change your grid to rectangular, you can see that, so we think that point's in the right spot. Let's just check it, because we know that that should be negative 5 halves, comma 5 square root 3 over 2. And sure enough, the blue point and the green point lie right on top of one another. Okay. So that's going from polar to Cartesian. Let's go the other way. Let's find the polar coordinates for the point with Cartesian coordinates xy equals -3, -4. So we're trying to go from xy to r theta. Now we remember that x squared plus y squared equals r squared. So that means that -3 squared plus -4 squared equals r squared, which means 9 plus 16 equals r squared, which means r equals the square root of 25, which is 5. And we can just take the positive 5, because we're going to choose the angle of rotation that gets us to the right spot. So let's think about where we are in our coordinate system. So we know we're going to be somewhere on this circle that has radius 5. So that's 5, and that's -5. And we know the Cartesian system says that we're going to be about here. So we're going to choose an angle of rotation that gets us to the third quadrant. And I say choose because we've got some choices to make here. So remember what we're doing. We know that x over r equals cosine theta, which means that theta is the inverse cosine of, in this case, -3/5. Now, -3/5 is not a special known unit circle value, so we will use Desmos. And we'll take the inverse cosine of -3/5, and we get 2.2142. That is not a third quadrant value, is it? That's less than pi, because pi is 3.14. So this is about 2.2142. But we remember that we know how to get to the other angle that has the same cosine, because theta might also be 2 pi minus 2.2142. Well, that should be 2143. My apologies. Okay. So that means what we really want is theta of 4.0689. Now, how can we check ourselves? Well, pretty simply, because we know that y over r needs to equal sine theta. Right? And we know r and we know theta, so we're going to check to see what 5 times the sine of, we think, 4.0689 is. And it should be -4 if we've done everything right. And it is. So that checks. So my r theta is equal to 5, 4.0689. Okay. So just like we can have Cartesian equations, we can have polar equations, and we're going to talk about that in the next video.